Hello, all listeners, and welcome to this episode of Hacker Talk. My name is Philip, and I will be your host during today's show. Today, we're going to deep dive into Wi-Fi chips, hardware hacking, Wi-Fi devices. And with me today is the hacker, hardware creator, Hack5 team member, creator of cat-shaped Wi-Fi hacking devices, cybersecurity content creator. Give a hand for our Hacker of the episode. Welcome to Hacker Talk, Alex Lynd.
Thank you so much for having me on. This is really exciting.
It's a pleasure to have you on. And I'm really excited to get your story and hear about all the cool hardware hacking projects you got going on. But for all our listeners that have no idea who you are, what's your background and how did you get here?
So the brief summary of what I do, I'm a cybersecurity content creator, as you introduced me. So I create primarily beginner-focused videos and tutorials on the Hack5 channel. So Hack5 manufactures all sorts of covert pen test gear like the USB rubber ducky and also things like the O.MG cable for any listeners that might be familiar with. And occasionally I also appear on some other shows like Security Forward, where I present information security and cybersecurity related news. Besides that, I'm also a hardware creator. So I'm the developer of the Nugget, which is a cat-shaped educational hacking platform. And in my free time, I also work on security-focused proof of concepts and tutorials around things like signals intelligence. So one of those things that we're going to be diving into today would be Wi-Fi hacking.
Awesome. How did it get started? Was there like a light bulb moment where you were like, oh my God, this is amazing? Or how did it all start?
So I actually started out more in the hobbyist hardware space, actually. So back in, I think, like middle school or so, I got into hardware hacking because we had these graphing calculators, specifically Texas Instrument TI-84 calculators. And I really wanted to figure out like how I could put games on it so I could like not pay attention in math class. So I taught myself how to program games on these calculators. And soon enough, I found myself like physically modifying them. So I learned how to like overclock it. My friends and I ended up like putting microcontrollers and like Wi-Fi chips and like all these other crazy things inside of our calculators to
That's really cool.
Rice them up. Yeah. So that got me a little bit into the hardware side of things. I started learning about like hobbyist microcontrollers, hardware hacking, that sort of thing. And then I eventually discovered probably the Raspberry Pi, actually. So the Raspberry Pi was my first actual computer that I ever owned. So obviously I had to get familiar with Linux. I started learning about like all these distros and then eventually went down the rabbit hole of like learning Kali Linux and like all these security things. My first experience with hacking though, so growing up, I was actually kind of poor, I guess you could say. So I didn't have internet at home. I had a lot of homework assignments and things to do naturally, but no way to actually turn them in. So with my newfound hacking skills, I suppose, and like all the things that I was teaching myself, pretty much the first thing that I taught myself how to do was how to hack Wi-Fi so that I could actually just like do my homework from home instead of having to go out to like coffee shops to do them. So once I learned like how easy that was and that like basically like hacking is just like a methodology and that you could like pretty much just learn all these things by just looking up like references online, I pretty much found that like anything that I wanted to do or like learn, it wasn't that hard if I like really put my mind to it. So eventually I started teaching myself about like other subject areas that interested me. I got a little bit more into like information security, embedded security, all sorts of things. So for me, it was actually more of a pivot from hardware hacking over to more of the InfoSec and cybersecurity focused things that I do today.
That's good to hear. So then you started making your own Wi-Fi devices and your own hacking devices. How was that? And how was that story?
Yeah, so as I mentioned, since I do have a background that's coming more from a hardware developer perspective, something that I've always been interested in for the longest time is making like low cost, like hardware proof of concepts and basically like disposable hardware, I guess you could call it. So a lot of my projects are focused around creating, I guess, like low cost and accessible like hacking tools. So like one of the most recent projects that I've been working on, which was featured about a month ago on Hack5, is this little GPS implant that you can stick on a car It's basically just an ESP8266, which is a $3 Wi-Fi microcontroller. It's a little GPS module and also some other like battery components and stuff like that. Basically what it does it's a little like Wardriving implant that you can stick on someone's car, automatically gathers and accrues like GPS coordinates. And when it encounters like an open Wi-Fi network, it'll just automatically upload those. It'll upload like location data, signals intelligence, and like other things that it's gathered like along the route. But I like creating like really low cost proof of concepts like that are mostly like microcontroller based, because I find that they're more accessible for beginners that might not have a big budget to use like a Raspberry Pi and like other expensive signals intelligence gear like Wi-Fi dongles, GPS dongles, and things like that to try out hacking. So I mostly got into this because not only did I not have a lot of money to work with, but since a lot of my stuff is really beginner focused, I also want to make this accessible for other beginners in the space who might not have a huge budget to replicate some of my projects. So one of the projects that I set out working on about a year ago was called the Nugget. When I first got started with hacking, I learned about like all these tools that were out there. Like I mentioned that I work for Hack5 now, but when I was first getting into the space, I learned about all of these different products like the USB Rubber Ducky, the Bash Bunny, the Wi-Fi Pineapple, all these other like off-the-shelf products that you can buy and use for like hacking engagements. To me, those seemed like a little bit nebulous. They were like a bit of a black box, in my opinion, they were a little bit hard to get started with, is what I'm saying. Like the barrier to entry can be a little bit confusing to someone who's like completely new to using these tools. So one of the problems that I sort of wanted to solve was making this seem less scary to beginners in the space. So I created a product called the Nugget, which just right off the bat is like a super cute product when you pick it up. It's this little cat-shaped tool that's it's an extremely friendly design. That's like the whole point. You pick it up, it's sort of a Game Boy-esque form factor. It has like a little D-pad that you can use. It has a screen, and also a nice little LED that gives you like reactive feedback while you use it. And also like little cat-shaped animations and like icons that pop up.
The design of it is amazing.
Yeah.
I know a friend of mine got one at DEF CON and he sent me a picture and I was like, wow, this is awesome.
Yeah. So the point is, it's supposed to be like not only a really friendly and intuitive design, because like, as I said, some of these other products, they're sort of a black box. There's no way to really get like a lot of feedback when you're actually using them. Mm-hmm. I designed this product to be super interactive and reactive as well. So the point is, when you're using it, it's supposed to be like a little guided tour of different hacking lessons, like a little classroom in your pocket, you could call it. So we currently have two variations of the Nugget. One of them is called the Wi-Fi Nugget, and the other one is called the USB Nugget. So since my specialty is mostly signals intelligence and Wi-Fi hacking, the Wi-Fi Nugget is a tool that's focused on teaching beginners about different topics in Wi-Fi hacking. So you can learn about crafting your own packets. You can learn about the authentication attacks and all sorts of things. And the USB Nugget is what we're currently selling through Hack5. That one's a little bit more focused on hot plug attack, keystroke injection attacks, and that sort of thing, since that's Hack5's specialty. So if anyone isn't familiar with what that is, I'm sure you've heard of the USB Rubber Ducky, right?
Yes, of course.
Yeah. If anyone's not familiar with what that is, it's basically a covert little tool that looks like a USB flash drive. You plug it into someone's computer and then, oh crap, it starts typing out like a bunch of stuff. It's basically designed to emulate like a keyboard, and you can pre-program it to just dump malware or type out like pre-programmed scripts into someone's computer. I
don't have a one of those, but I have one of those AT microcontrollers that do exactly the same thing.
Oh, nice. Yeah, like AT Tiny.
Yeah, exactly.
Yeah.
AT Tiny.
Yeah, that's where I got started too. It's like back before I could afford buying all this expensive gear, I was just like learning how to replicate them for cheaper, like on the down low, using like an AT Tiny 85 or like other microcontrollers and stuff like that. That's another thing I guess we'll talk about if you want to remind me. Before I learned how to like do most of the things that I was doing like on the Raspberry Pi, like Wi-Fi hacking and stuff like that, I was also trying to teach myself that using entirely microcontrollers. And it's actually one of the great use cases of the chipset that's currently inside of the Wi-Fi Nugget. But anyways, I digress. Where was I? Oh yeah, so the USB nugget is more focused on USB attacks, and it's designed to make it easy for beginners to learn about how you can construct different payloads and run all sorts of like hot plug attacks when it's plugged into someone's computer.
So there are two the different types there. But let's jump into the Wi-Fi nugget and the kind of design pattern behind it. What did you kind of cherry pick, and what did you want the Wi-Fi nugget to do? I know, like when I do wireless pen test, or I try to crack my neighbor's Wi-Fi with permission,
right?
I use something called Wi-Fi, which is basically a Python script to utilize what's called O.MG for
air crack.
Air crack, exactly, for the authentication.
Yeah, I've seen a lot of great sort of wrapper tools for that. Are you familiar with Airgeddon? That's one that I used for the longest time.
Yeah. That's an awesome tool.
That's one of my favorite scripts. Nice. Yeah, so sort of the design process for the Wi-Fi nugget, it's actually a lot more chaotic and less well planned out than a lot of people think. So initially, where this came from, so the Wi-Fi nugget basically just started out as a kit. So if you look at the current design that we're selling, if anyone wants to look up Wi-Fi nugget, you'll see that it's basically completely like through hole parts that you can assemble and solder together yourself. So this actually didn't start out as any sort of attack tool or even like a cybersecurity like education focused platform like at the time. So when I first started working on this project with my friend Cody, he had a bunch of hardware components that were left over from like a previous project that he worked on, which included like a bunch of D1 minis, which are basically just ESP8266 Wi-Fi chips. He had a bunch of screens and like leftover buttons. He was sitting on a stockpile of somewhere around like 500 of these things and had no clue what to do with them. So he was like, if you want to design some sort of like educational kit or something like that beginners can solder together, then maybe we could find a way to get rid of all this extra hardware crap that I have on hand. We can run like workshops, maybe sell it online or something like that. But basically just tasked me with like designing a kit that beginners could put together. So that way we could like sell all this stuff he had on hand. So my idea was to create a little cat-shaped board, because who doesn't like cats? That utilize all these components. So we used the screens, we used the Wi-Fi microcontroller, and then also the buttons. And that's sort of where this design came from. In the beginning, it wasn't exactly doing much. We were just running like existing open source software that was out there. We were actually there's a really great creator, Spacesoon, if anyone wants to go check him out. And I'm sure most people will probably be familiar with him. He's pretty popular in the maker community and the maker space for his ESP8266 and ESP32 focused projects, specifically the Dialpha project. But that was the initial software that we were running on this design. So it was basically just a toolkit that allows you to select nearby Wi-Fi access points and Wi-Fi devices and things like that, and be able to run some basic attacks on them. So you could do things like deauthentication. You could also run like a beacon spoof prank, where you could just create like a whole bunch of spam like Wi-Fi networks to prevent someone from connecting to their home network. And there's also like a really great command line interface that you can connect to. So you can basically like plug this into your computer, pop open a terminal, connect to the Nugget /ESP8266 over a serial connection, and be able to run custom attacks by like crafting packets over this CLI. So that's initially what we were selling it with. We were just running some open source software on it. And it was sort of this just like raw circuit board kit that we were selling. To be honest, at first I didn't expect it to sell a whole lot. So we just created like a small batch, I think somewhere around like 100 of these designs. So we basically just threw them up on our Shopify store. I created a YouTube video on the Hack5 show, like demonstrating how to use this as a basic attack tool. But very much to my surprise, we sold out of these things like within 2 weeks. And I was like, oh crap. Like,
that's awesome.
I was like, maybe we should do a second run of these, and maybe I will put like a little more thought into the designs. Because like at this point, the initial idea was we were going to sell these like at workshops, because I do host like a lot of in-person events around the LA area where I teach beginners like how to solder and things like that. but almost all of these sold out like completely online. So after that, I decided to put a little more effort into the design process. We manufactured some 3D printed cases. We made it a little more polished. I started including like circuit board art. And the current iteration that we have today is now a surface mount design that I'm about to put into production soon, I'm hoping. But this kit version is also still around. And I find it super, super engaging and beginner friendly. And it's a really fun like centerpiece for the workshops that I host. But that was sort of the design process for the wifi-nugget.
That's interesting. That just a side project or just do something with these parts and then it turns into something really cool. So I know
there's like so many details. Oh, sorry. There's so many other parts that I could like ramble on about, like all the supply chain and like logistics stuff that we had to do. And I'm also skimming over like the surface mount design process. But yeah, it pretty much started like serendipitously.
I know a lot of our listeners are very familiar with the ESP32 Wi-Fi chips, but if you were to pitch the ESP8266 Wi-Fi chip, what is the difference there and why is it popular?
I do have to say that I'm liking the ESP32 a lot more now that I've been working with it more closely, but that is a dichotomy that we have in our product. So as I mentioned, we have the wifi-nugget and the USB-nugget. And currently, these are using two different chipsets. So the Wi-Fi-nugget uses the ESP8266. And of course, it's the Wi-Fi attack focus platform. And the USB-nugget is using the ESP32S2. So the primary difference between these chips, at least when it comes to functionality for the attacks that we're doing, the ESP8266 is a lot better for Wi-Fi attacks. And the reason that this is, it's a lot older of a chip. I think it's been around for some number of years, maybe like 5 or 7, or even longer than that. But back in the day, Spaceman actually was the one who discovered this. You can use these chips, and the Espressif software development kit, their SDK, actually allows you to construct arbitrary packets. So this allows you to construct things like the authentication packets, disassociation packets, and stuff like that, and be able to run like arbitrary Wi-Fi attacks. And their software development kit at the time completely allowed that using like an arbitrary packet write function. The problem is Espressif didn't really like that. So when they developed their newer line of chips, which is like the ESP32 and all the subsequent lines that have come out, like the ESP32C series, S series, and stuff like that, they basically decided to lock down their software development kit and get rid of the function that allows you to basically spoof arbitrary packets. So that essentially like removes the ability to run arbitrary Wi-Fi attacks, which completely sucks.
Yeah,
so
that's awful. Is that like permanently, or is it just, we don't know?
Permanently, because they don't really condone doing Wi-Fi hacks on their chips, which sucks.
Okay.
However, I have seen and tested some work on the ESP32, the regular ESP32, not the C or S series yet. Someone was able to reverse engineer the software development kit to run Wi-Fi attacks on the ESP32 as well. It's a little more shaky.
Nice.
There's not a lot of support for it. But just historically, the 8266 is a lot better for running Wi-Fi attacks. Spacetune has a crap ton of work that's developed around using it as an attack platform, like as the author software. So it's just generally better for that. And it's also lower cost, which is a good benefit. When it comes to the ESP32 line of chips, these are a lot more sophisticated. And one of the really cool features about, well, as I mentioned, the particular chipset that we're using for the USB-nugget is the ESP32S2. And one of the really cool features about that, that the other chip doesn't have, is something called native USB. So basically what this does is it allows the chip to act as a native USB controller. So this allows it to emulate things like USB devices, which obviously we're using to run keystroke injection attacks. But this can also be used for things like emulating a mouse, for example, if you wanted to like stimulate productivity and pretend like you're doing work, you could create like a mouse jiggler or something. Or you could even have it emulate all sorts of other like HID devices or like a USB Ethernet controller, for example, for data exfiltration or all sorts of other really cool stuff. But generally, the ESP32 is a lot more powerful. But again, there comes the limitation of not being able to do as sophisticated Wi-Fi attacks.
Yeah, that's kind of sad that you can rewrite the arbitrary package chip.
Yeah. Yeah, I've been looking a lot into that, though. I am hoping that at some point in the future, we can consolidate like all this work onto a single chipset, because the ESP32 is a much more powerful platform. I've used it for Wi-Fi reconnaissance. So, that is one thing that it is better at that you're still able to do. It's a lot more powerful for Wi-Fi recon. So you're able to, one limitation that's always been there actually with the ESP8266 is that since it's not that powerful compared to the 32, one annoying thing that it does do is if you're gathering Wi-Fi reconnaissance, it'll truncate part of the Wi-Fi packet. So essentially you can like sniff for regular packets, right? You can sniff for things like probe requests. You can sniff for like beacon frames, and you can basically get an idea of what sort of things are happening like over the Wi-Fi landscape, but you're not able to get like a full view, the actual data that's being exchanged. So for example, if I wanted to like capture all nearby Wi-Fi packets and like decrypt them later and like see what sort of websites people are visiting, I'm not able to do that since it's like truncating part of the packet.
What's the reason for truncating part of the package? Is it the limitation on storage, or?
I think it's the storage limitation, probably the RAM or something like that. I actually haven't looked into it. But it basically discards like important parts of the packet and also limits like the ability to capture Wi-Fi handshakes. One really cool thing about the ESP32 though is although Wi-Fi attacks are locked down, it's still really good at reconnaissance. And this opens up the ability now to like capture full Wi-Fi handshakes. So in theory, you could use it for like capturing handshakes, decrypting like the actual passwords themselves and things like that. And you can even run like more sophisticated attacks like PMKID.
That's interesting. There you touch upon a really interesting thing. I think that's like decrypting the handshake. What's your best practices for decrypting VPA handshakes? Do you have a giant GPU farm that you just throw the hashes on, or
no? Google does. Google has a free GPU that you can tap into. Yeah. So my general process actually, when it comes to decrypting passwords, I run through a little checklist. So basically the first thing I try is see whether or not it's a default setup of some sort. So I find that a lot of people are just complacent when it comes to like setting up their Wi-Fi, and I'll encounter like a lot of just like generic setup access points like my Spectrum Wi-Fi or like Spectrum setup 66 or something like that. Most of the times these will have default passwords set up, and these are usually structured in a way that's like programmatic at the factory. So like, for example, one really popular combination for like my Spectrum Wi-Fi, whatever, which is a really popular network, is usually going to be a noun, an adjective, and 3 numbers. So those are actually pretty easy to crack. There's a service called Google Collab. I actually created a video on this. I hesitate. You guys can look into this. I will not admit to doing any sketchy things with this. But in theory, I've heard that it's possible to use this online service called Google Collab, which is designed for training machine learning models. It gives you access to free Google GPUs. I heard in theory it's possible to run Hashcat on these instances. And even cracking passwords. Have I done this in the past? Who knows?
Okay.
I've seen this used to crack multiple default passwords like that. Some other things that I run through, usually running it past a password list of the local area code also works pretty well. So I use like a password generator for my local area code, like 714 or like 213 or something like that. And I can usually run through that pretty quickly. Or running like a top like 10,000 passwords list has also worked a surprising number of times.
What do you think works the most? Is it the default password list, or what is the best throughput?
Generally, like when targeting Wi-Fi networks, I try not to go for things that are like custom Wi-Fi networks. So I'm usually targeting things that I can obviously see are like default setups. And I've had really good luck with just trying like the noun, adjective, 3-number password list.
Nice.
Yeah. How about for you? You said you've also done some Wi-Fi stuff.
Yeah. Me personally, there's actually, I don't know if you know him, but there's one guy called Mike Spicer who does the Wi-Fi cracking. and he told me that phone numbers is really good. So
Yeah.
for me, I have a
Wait, is the Wi-Fi cracking that one with it's the one that captures like all that Wi-Fi traffic, right?
Yeah. Mike.
I was thinking of the Wi-Fi cactus. Is that the same guy?
Yeah. It's the same guy. We actually had him on the show in the previous episode. So all listeners, you have to tune back and listen to that. But awesome. Yeah, he told me he got various the one called from Hack5, the Wi-Fi pineapple.
Yeah,
is that correct? Yeah, he got like 8 or 10 Wi-Fi pineapple and connected them with an Intel NUC, I think. Anyhow, he gave me good tips using phone number. So for me, what mostly works is I have a default password list of just regular 1 to 8 and password and stuff like that. It's maybe 2,000 passwords, and then I do the phone number list as well. But there's always it's always interesting to hear how other people do, because there's always some hashes that you just sit and look at the progress bar, and then you're like, what can this be?
Right. Yeah, phone numbers work really well for me. You've probably heard of do you know Daniel Messler's security lists?
Yes.
Yes. Yeah, that's a really great reference. I usually run through those as well.
Yeah, those are really good. And everyone used to be like, I think like everyone used to be like, you have to use the RockQ. Have you heard about the RockQ word list?
Yeah, that's just like the default one on calculus.
Yeah. So everyone's like solve all word problems with the RockQ word list, but I haven't had so much super success with it. I'll tell this though: the best password cracking list I ever got, with the most successful, was from there used to be this hash cracking forum called Hashkiller. It was based in the UK, and I don't know what happened, but the domain has been inactive for 3 years, I think, or 4 years. So I don't know what happened to them, but they used to it was just basically a forum where people uploaded their cracked hashes, and then the administrator published a nice, like a CSV file of this is the top most used hashes and most used password.
Nice. Is that the distributed cracker one? So I remember a tool like that existing. I don't know if that's...
No, that's different, I think. I think those are different.
So it's basically just like a rainbow table though of existing...
Exactly.
Nice.
Exactly. Yeah, but let's jump back to attacking with the wifi-nugget.
Yeah.
What's the most popular use case for the wifi-nugget right now?
I would say mostly pranks, honestly. Awesome. A lot of people in our forums are just talking about like kicking their kids off Xbox once they've been online for too long, or things like that. Yeah. Actually, one thing I do want to mention is over the past couple months, we've been shifting our focus towards developing mostly the USB nugget. So we haven't like developed as much for the Wi-Fi nugget, but something that I want to get back into. Hopefully soon, but I'm hoping to develop more educational content around it, and also develop the interface a little bit better to make it a little bit more gamified and like actually walk users through the hacking process and like make it more intuitive to use. Right now, or at least like up until very recently, we have still been selling it with the author software. But about a couple months ago, I created my own custom firmware for it called the Nugget Invader, which is basically a Wi-Fi attack / network defense toolkit for the Wi-Fi nugget. I've been working on developing that and honing some features for it that we could maybe talk about.
Yes.
But, yeah.
So you have the Nugget Invader and the Nugget Defender. What's the difference there?
Yeah, that's where nomenclature gets a little bit confusing for you listeners out there. Yeah, so currently there's 2 pieces of supported software that run on the Wi-Fi Nugget that I've been working on. So the Nugget Invader has a more offensive focused. So this is more focused on running Wi-Fi attacks, network intrusion, and all sorts of other naughty things. So you'll find like the authentication attacks, beacon spamming, and all sorts of other things under that umbrella in the Nugget Invader toolkit. The Nugget Defender is more focused on network defense and Wi-Fi security. So some tools that we include on there are honeypots. So you can basically catch people that are trying to break into your network. There's a deauthentication attack detector. So you can see if anyone's like trying to, run an attack against your Wi-Fi and some other things like that. What's really cool about the honeypot, though, I've actually been working with this service a lot recently. Are you familiar with canary tokens at all and how that works?
I'm a bit. I have never used them personally, but I saw the Black Hat talk on them. What are canary tokens?
Yeah, so canary tokens are super versatile. They're basically this free online service. You just navigate over to canarytokens.com. Really simple. They have like this little drop-down menu where you can select between a bunch of different honeypot types. And they're basically just an online service that allows you to create custom honeypots like in just a couple seconds that you can deploy to things like a bugged Microsoft Word document, a bugged web image, a bugged like URL, or all sorts of other different formats, and basically use this in order to detect if someone is trying to break into your system. They're just super great. It's a really novel solution and it's like super easy to work with. The use case for this though is it's meant to be extremely easy to generate these sort of different like bugged items that you can use in order to detect if like someone has access to like a confidential part of like your network, or if someone like clicks on a specific link that you might send them. One of my favorites is this bugged image that you can send. So for example, inside of a lot of like messaging systems or messaging services like Slack or Signal or Skype, you'll see that when you send someone a link, oftentimes it'll generate a preview image that shows you like the favicon or like a thumbnail for like the website that you're about to visit, right?
Yes.
Canary tokens, one of their honeypot solutions is they offer a bugged web image, where basically you can send this to someone and see whether or not they viewed your message based off if that image renders inside of their messaging service. So you can use it as a sneaky way of determining like if someone's actually opened your message or not.
How do they know if the person that opens the message, is it based on the HTTP headers or?
I'm actually not sure what they use for the underlying thing for that particular token. Each one works a different way. They also have like bugged Microsoft Word documents as well.
Cool.
And bugged like PDFs and all sorts of other things. But yeah, Canary tokens is extremely useful. I use it for a lot of things. I've also demonstrated it in the past for stuff like detecting Log4j vulnerabilities, for instance. Most recently, I also used it in one of my demonstrations on Hack5 for DNS exfiltration. They offer a DNS canary token that you can use for exfiltrating data. Yeah, in a subdomain, which is really cool. But what I'm using it for in the Nugget Defender is actually just basically for the honeypot feature. So basically, the second someone tries to connect to the wifi-nugget, which you can use to masquerade as like a random IoT device or a printer or some other sort of vulnerable service, it'll trigger a canary token alert and send that directly to your email telling you that someone has breached your network and is trying to hack into your stuff.
That's awesome. It's like having an IDS or an IPS just in your pocket.
Yeah. One of the features that I was also trying to work on in a similar vein was like the second that that's detected, it would try to deauthenticate the malicious user that's trying to access.
That would be really dope.
Yeah. Problem is though that it doesn't really work if they're like wired. But yeah.
How does that work? Does it capture the MAC address or the host name of the bad actor and then puts that on a block list or something?
In theory, yes. I haven't actually started working on it. I've thought about it, and I think that's the way it would probably work. Like you would be able to detect their MAC address, given that they're on the same network, and then kick them off. If they're doing something like just running a deauthentication attack or something where they don't actually have to be connected to the network, obviously there isn't anything that I would be able to do about that, though.
I know we have a lot of like listeners that are really into hardware hacking and designing their own PCBs and stuff like that. How was the journey for you to like put together a PCB, and has there been any learning mistakes, and has there...
a lot of mistakes.
Tell us about that.
I guess you want to get like my background and how I sort of got started in designing circuit boards, or?
Yeah, and your overview.
Okay. As with most things that I've tried to teach myself, I had no clue what I was doing when I first got started. With most of this, I sort of just saw like other creators and YouTubers and stuff like that designing their own circuit boards, and I was like, crap, I really want to do that. I didn't really know where to start though. I found this online service called Easy EDA, which is a really simple design suite that you can use for designing schematics and circuit boards and things like that. It's super intuitive. You don't need to really install anything. You can just go to their website, design a schematic. Typically, you'll design your schematic modeled after a physical hardware prototype that you've created, like on a breadboard or something similar. And it's just like block level stuff. You'll pick out like a schematic diagram for like an LED, and then pick out a schematic symbol for an Arduino and just like connect the wires. Pretty simple. And then you can use this service in order to generate like what's called a netlist. You can dump it into like a unrouted circuit board, and then using their online EDA service, you can start like wiring it up, creating like the board outline, adding copper fills and like all sorts of other fancy stuff.
It's a bit like drag and drop then.
Yeah, it's very much drag and drop. It was really intuitive to get started with. When I first got started with this, though, as I mentioned, I didn't really know what I was doing. So the very first circuit board I ordered didn't work because I forgot to add a ground copper fill that actually like connects all the ground traces together. So I only had like my data lines like wired up, but nothing was actually connected to ground. So I screwed that up. But after watching a couple tutorials, I figured out how to actually get that working. The very first circuit board I designed, though, was pretty simple. I think it was just like a little replica of the Adafruit TV Migon. If anyone's familiar with that project, it's basically just a little kit that turns off most TV manufacturers by just blasting out infrared signals. So I basically replicated that project over the parts online and was able to solder it together myself. After that, I eventually taught myself how to use KiCad, which is a little bit more sophisticated of a design tool. It's like a full-fledged PCB design software that you can install on your desktop. It works across all three of the standard operating systems, Windows, Mac, Linux. I find it super versatile. It's also free and open source, and I use it for all of my projects today. And also what's really great is once you learn like a really simple EDA, like Easy EDA, which is the one I got started with, the skills are pretty much transferable. So I was able to pick it up in like less than a week or so.
That's interesting. So when you have your PCB design ready, where do you source it from? Do you send it to a hardware vendor, or how do you get it in your hand?
Yeah, so the service that I've been using for a while, who is also my sponsor, actually, this is a great moment to rep them. PCBWay, they offer a great PCB manufacturing service and also sent me a crap ton of PCBWay merch for the holidays. So shout out to them for that. Typically, there's a lot of online PCB manufacturing houses overseas that offer really great prices. PCBWay, for instance, is one of them. There's also some domestic places that you can source them as well, like Osh Park is a really great one here in the United States. I think JLC was the first place that I tried out initially, since they offer integration with the Easy EDA suite. You can just like directly place an order like right from the website and then have them shipped to your house. I find though that PCBWay their prices are a lot more reasonable. They have like a lot of better options when it comes to like circuit board finish and like the different colors and things that you can select. And also the quality has just been like generally better for my projects. But it's super simple. After you finish like designing your circuit board in whatever suite that you're using, you just export it to a file format called Gerber, which is basically just a manufacturing format that tells the machines like how to drill the holes, how to plate the copper, and all sorts of things like that. You just upload that file to a website like PCBWay.com, plug in your address, and then pretty much you just get the boards like 2 weeks later.
Oof, that's amazing.
Yeah, it's really fun. It's fun, really. Have you ever designed a circuit board yourself?
I have tried to design a circuit board myself, but it wasn't working.
What was the design?
So I got really this is a real sidetrack, but I got really into automating like plant growing and stuff like that, because I used to grow a lot of chili and also coffee plants. So I had my Arduino and all my sensors and all the breadboards and everything, and it wasn't like looking so super pretty. So I had thoughts of like actually doing a PCB on it, and actually building a proper device for it, and not just having water cables and jumper cables everywhere.
Nice. If you ever want help with that in the future, maybe I could help you out. That sounds cool though. Yeah, I've also been working on some similar related plant things, because I find that I've been neglecting them. I haven't been watering enough. So I've been working on an automated watering system, automated composting system, and some other designs like that.
It's really fun when you get it to work, and then it just automatically goes on every day. It's like a real life cron job, I would say.
Yeah, it's super rewarding. The designs are also just like really fun though. I've been dabbling in circuit board art recently too. As I mentioned,
nice.
The Nugget. Yeah, the Nugget is a cat-shaped circuit board. But more recently, I've been working on creating like specialized graphic art and some other really like sexy features for my designs. Yeah, and with the surface mount version that I'm hoping to release at some point in the future, there's some little cute like pixel art on the circuit boards, like some gold inlays and some other really.
How do you get the artwork on the PCBs? Is that something the manufacturer needs to solve, or?
So first, when it comes to actually designing the art, you can't do that natively inside of the design software usually, like EasyEDA or KiCad. So I have to use a vector design tool, like Adobe Illustrator or Inkscape, for example, and I'll just create my art there. There's really great plugins that make it really easy to do that. Like SVG to Shenzhen is a really popular add-on that you can get for Inkscape, which basically lets you create different graphic layers and automatically export it as a KiCad PCB file. But basically, nice. I just go into Inkscape, I draw up my art digitally. Sometimes I also use GIMP as well for creating my pixelized art. Dump it all into Inkscape. I use this SVG to Shenzhen tool, export it to a KiCad board file. And then from there, I started doing my actual routing and component placement and stuff like that. And that allows me to create the actual graphic art. The way that it works when it comes to manufacturing this is this process takes advantage of just the different like finishes that come on the PCB naturally. So the color palette that we're working with isn't exactly the largest. What we have is just like the silk screen, which is like the color finish. You have the actual material itself, which is usually like a gold or silver metal color. And then you have the silk screen, you have the material, and then you have, I'm forgetting the name for the finish. But anyways, there's like usually 3 colors that you can work with for color palette. These are all just basically the materials that are already on the circuit board, and you can manipulate them in a way that you can create like a 3-color sort of design.
That's dope. That's dope. I had no idea about that. So
yeah,
after you source and you solve the PCB, you need all your chips.
Yeah.
So, and how did you think about the IC chips for the wifi-nugget? Did you want to give it a certain amount of space, or what's the thought process there?
Like the layout sort of thought process?
Yeah.
Yeah. So as I mentioned with the initial design, that one just started out as a sort of like solder it together kit for workshops and that kind of thing. So the layout wasn't too complicated for that. There were only about 3 or 4 components, really. You just had the screen, like the microcontroller, and then also the buttons. And as I mentioned, these are mostly through-hole components, so that way beginners can actually like solder it together themselves. So the layout for that wasn't too hard. I just put the microcontroller on the back of the board where no one would see it. I put the screen on the front and also the buttons on the front side as well. We actually did run into some design paradoxes, though, since if you assembled it in the wrong order, you could actually like block off access to certain pins that had to be soldered to. So for example, if you accidentally soldered the screen first, you wouldn't be able to solder down the microcontroller since those pins are hidden behind it, which kind of sucked. More recently, I've been working with SMD or surface mount designs, which are a lot smaller. And that's where you get into more complicated design layouts and stuff like that. These are really tiny components that are about like the size of a rice grain. And things are a little more complicated since you have to really think about things like radio frequency, interference, and other things like that when you're actually placing all of these components. Luckily with the original design, I didn't have to think about any of that since we were just using off-the-shelf modules that you could buy on like Amazon. But I also didn't have the experience at the time when it came to surface mount layouts. But now that I've been doing that more recently, it is crucial to think about things like where the antenna is actually placed, making sure that there's enough clearance so it's not interfering with any of the components, making sure that things like capacitors are close enough to signal lines so they're actually like filtering out any interference or like fluctuations in voltage, and also like choosing the right components like ferrite beads to prevent from like electromagnetic interference on like the USB line and stuff like that. I've been mostly like teaching myself as I go along the process. Luckily, I have a lot of friends in the community that have done this like professionally, that I can just like send my board designs to and be like, hey, like what's wrong with this board? Like, is it screwed up? Like, and usually they'll be able to give me some pointer for things that I should change.
Is there a way to like emulate the board so you know that your PCB board works, like virtually emulate it? Or
yeah, there's a lot of I haven't seen any for emulating like the efficiency of the circuit board layout itself, but there are tools that you can use to emulate the actual like signal processing and things like that to make sure that your design is like actually functional. But as far as I'm aware, like when it comes to the actual board layout itself, like that's pretty much on you, and it's pretty much on experimenting once you receive the physical thing. I might be wrong, but yeah, what I've been working on recently though is mostly learning about ways to prevent against electromagnetic interference. So one of the things that I included in my recent iteration of the surface mount design is ferrite beads, which are super useful for just filtering out any sort of noise that might infiltrate over USB connections. One thing that I do want to get into though is antenna design, which is a little bit over my head right now. But it turns out there's like a lot of different interesting ways that you can implement antennas onto a circuit board. You can either get pre-existing components that you can just stick on there, like surface mount components, or you can actually like manipulate the traces on the circuit board itself and use that as an antenna. But the actual like tolerances and dimensions and stuff like that, and the amount of like clearance and filtering components you need for that can be a little bit complicated. But I'm interested in learning how to do stuff like create a directional antenna on a circuit board. Because I've used directional antennas for a lot of my Wi-Fi hacking stuff. Those are super useful for being able to just point it in like a specific direction and just get like a mile line of sight range for like Wi-Fi hacking and stuff like that. I've been learning about antenna design like over the past few weeks, but I really want to learn how to create a directional PCB antenna. I think that'd be super dope, and hopefully integrate that into future projects.
That would be really dope. Have you been playing around with some antennas?
I've been playing around with just off-the-shelf ones for now. So just like Yagi antennas, all sorts of omnidirectional antennas, patch antennas, stuff like that. And I've been ordering like a few just to test them out. I've been trying to learn about how to create like completely integrated like circuit board ones, as I mentioned, but the math is going a little bit over my head, to be honest.
Yeah, I know there's a lot of there's a lot of people in Germany that do a lot of antenna research. There's some cool things going on there, especially with like satellite antennas and the entire Iridium.
Oh, nice.
The Iridium spectrum. Yeah. That's, I think that's really cool. Yeah, the Yagi antenna, I feel like those are the most popular like consumer wide range antennas that keep popping up.
Definitely, yeah. When it comes to directional, at least I've seen like just the standard, typically the standard like little omnidirectional antennas that come on like routers and stuff like that. Those are probably the most popular, and you see them a lot. like Wi-Fi dongles and routers and things like that. But the Yagi is an extremely popular design. One that I've been wanting to create for a while, though, that's pretty cool. Have you ever heard of the Cantenna?
No, what is that?
Oh, so it's basically just a design that utilizes like a Pringles can or a soup can as housing for an antenna.
Oh, yes. Yeah. Yes. Now when you say it, the Pringle can. Yeah, that I've heard.
So I've been wanting to do that for a while and test that out. That seems really cool. But I want to attach that to like a stepper motor and be able to stick that like on top of my roof. So that way I can just like control it from inside and point it at like random houses.
Nice. Then you get the best coverage from there as well.
I would say. Yeah, but as I mentioned, like one of my biggest goals when it comes to designing a lot of the hardware stuff that I do is creating like low cost and accessible like hardware for beginners. And one of the areas that I want to explore is when it comes to antenna design, because sometimes buying some of these antennas can get quite expensive. And I think it'd be really cool to manufacture them in as small of a footprint as possible and for as cheap as possible.
But how do you, let's jump into like picking hardware and stuff like that. How do you pick the microcontrollers that you work with? Is it like, this is cheap and cool, I can do a lot of fun stuff? Or how do you pick your hardware?
So there's a lot of really renowned and like big name brands that exist, like Espressif, which is known for like their Wi-Fi and IoT application chips, or like Nordic Semiconductors, which makes like all sorts of other RF related stuff, like little radios and Bluetooth chips and things like that. So generally, I've had luck like between these two manufacturers with most of my signals intelligence related products. I'll just be like, okay, I need a 2.4 gigahertz radio. I'm just going to go browse like Nordic Semiconductors and see which one is the most applicable for me. In that case, like in the past, I've used the NRF24L01, where I'll be like, okay, I need something that has both Bluetooth and radio functionality. And then I'll run into like some other chip, usually like on the Nordic site. I haven't really experimented with many other chips besides the standard like Espressif AVR chipsets and also Nordic. But usually it's just as simple as doing like a Google search and just reading through like manufacturer information spec sheets and just seeing if they match like all the different specifications I need. So usually this will be like some sort of wireless application like Bluetooth, Wi-Fi, LTE, or some other sort of radio frequency. Different hardware peripherals, like the ability to communicate with hardware sensors over protocols like UART or SPI or things like that. And then I'll also see if they meet like some other functionalities that might be cool to have, like if it's like dual core. Like one of the really cool things that I liked about the ESP32, for example, when I was looking for a chip that could do keystroke injection, was not only does it have the ability to do native USB, it also has like a low power mode that I thought was really cool. It has a built-in like cryptography chip that accelerates its ability to do things like create cryptographic hashes like AES, SHA, and all sorts of other popular hashes. And of course, like the ability to do like Wi-Fi, and then for some chipsets like Bluetooth on top of that. So it's mostly as simple as just like running a quick Google search and making sure the spec sheet like matches what's in line with my project.
Yeah, checking the data sheets and pick what you want and pick what you need, so to say.
Yeah,
so,
yeah, more or less.
Where is the future of the Wi-Fi nugget? Where is it heading? Is it more and more features, or what's coming up for the Wi-Fi nugget?
Not at the moment. We've taken a little bit of a break on the project right now, to be honest, since we've been focusing on the USB nugget.
Yeah.
I have been looking to do more stuff with the Wi-Fi nugget, though, since it's by far most popular between the two. I think the future of it is probably to focus more on education than features necessarily. These two things go hand in hand, though. But we're looking to develop the education side of things a little bit more, since that's really what our brand offers over other hacking products that are out there. I think what's more important is creating more educational content and making those things like more accessible for beginners to learn about the features that already exist on this product. Because as I mentioned, we already have like the Nugget Invader, the Defender, and then also some people are running Spacehoon's The Author on this product. So I think the next step is probably to create more educational content around the platform before we go out and develop more sophisticated features. So that way our existing user base like actually knows how to use all these things. So I think where I want to take that is there's this really cool feature that we've been using for a while called Web Serial. I don't know if you're familiar with it, but it's basically an experimental feature where certain browsers like Chrome allow you to interact with microcontrollers like completely over a web browser without having to install any other sort of software. But this is really useful for being able to like flash new firmware, interact with it over a command line interface from your web browser, and do all sorts of other really cool stuff. But I've been wanting to develop.
So the browser reads the serial interface, or
yeah, you can interact with it.
Oh.
Yeah, so I've been wanting to create like little online lessons that you can use where you can plug your nugget in your computer, be able to like do online, I don't know, like trivia, like answer questions and like run through a little lab, and do all these things from the web browser and be able to like get reactive feedback on the product. So that way you can basically like carry the same. So the cool thing is Web Serial also works, or rather a serial connection also works on your phone as well. So in theory, what I want this product to be able to do is like you can carry this around as like a little learning tool in your pocket, connect this to your phone or your laptop or basically any other device and have this just like ready to go. Like it's in your pocket. You can use it as like a hacking tool.
That's so awesome.
Like practice. Yeah, you can also practice like your lessons anywhere.
That would just be great for like user adoptability, making it super easy, like just point and click in your browser. That's really dope.
Yeah, pretty much. That's where I want to take it. That's not where it's at right now, but I have a lot of ideas when it comes to the education side of things. Besides that, like that also includes like refactoring the actual built-in interface to be more beginner friendly. Right now, it's still a little bit, I don't know, it makes some assumptions for the user that they already have like some sort of knowledge when it comes to like Wi-Fi hacking and stuff based off how the interface is laid out. It's still more beginner friendly than existing tools like the Wi-Fi Pineapple or other things like that. But I want to make it just like dead simple for a user to just like pick it up and figure out like what to do with it. Like one of the conversations I was actually having with a friend like a week ago was I want this thing to basically be like a children's toy. Like, are you familiar with Bop It?
Yes.
Yeah, I want it to be like a Bop It. Like you pick it up, you know what to do with it. Like you don't have to read an instruction manual to like figure out how to use this thing. Because one of the biggest pieces of feedback I get at like some of my workshops or like people that buy this product is there's still some sort of like guidance required or like the assumption that like users already know like a little bit about like hacking or like some technical stuff. But I just want it to be like so dead simple that you plug this into your computer, like a little cat pops up like on the LCD screen and then like walks you through like beginner friendly lessons and teaches you how to use the actual product without like making any assumptions for the user's like skill level. One of the hardest parts about like designing this product though, and this is actually a talk that I'm going to be giving in a couple months at a conference, is balancing the features to be both beginner friendly and also like extensible for more advanced users has been like probably the biggest design challenge up to this point. Because I wanted to create something that sort of like straddled the line between like beginner friendly, but also useful for like a more advanced audience. So that's probably like our biggest pain point, which is like developing features that like advanced people would use while also making it like simultaneously beginner friendly. And that's still a struggle that I am trying to figure out. But I think now that we have like a lot of, since we have like most of the advanced features nailed down, I think it's time to like take a step back and create more educational content, like beginner friendly stuff oriented around that.
Sounds awesome. So Alex, thank you so much for taking time with me today. Is there anything that you would like to mention that I have forgot about or anything that you would like to dive deeper into?
Not off the top of my head, but I would love to come back on the podcast again sometimes.
Absolutely.
Yeah, and if you do want to check out my work, people can find me on Twitter at Alex Lynd. That's Alex Lynd. You can also find me on YouTube as well on the Hack 5 show. You can check out my website, alexlynd.com, for more information. And also, yeah, thank you so much for having me on the podcast. This was awesome.
It's been a pure pleasure. And for all our listeners out there, all those links can be shown in the show notes under the show. So you got those there. Awesome. It's a wrap. Alex, thank you so much for joining Hacker Talk. I had the pleasure. I learned so much about the Wi-Fi nuggets, about Wi-Fi chips, and I hope to see you in the future.
Yeah. Thanks for inviting me. I'll catch you next time.
To all our listeners, thank you for listening to Hacker Talk, and I'll see you in the future.